Tree diagrams are a really useful way to show conditional probability. In this example, tennis great Roger Federer made 63% of his first serves in the 2011 season. When Federer made his first serve, he won 78% of the points. When Federer missed his first serve and had to serve again, he won only 57% of the points. This is illustrated using a tree diagram. So the first thing we know is that 63% of the time he made his first serve. So we know that 37% of the time he missed his first serve. This would be the given information in the conditional probability tree. The conditional probability is that when he missed his first serve and had to serve again, he won only 57% of the points. When he made his first serve, he won only 78% of the points. So we can say that given that Federer made his first serve, he won 78% of the points. So given that he made his first serve, 78% of the time he wins his point, so 22% of the time he doesn't win the point. These are conditional probabilities based on the given that he makes his first serve. Then we have another pair of conditional probabilities based on the given that he missed his first serve. There's a 57% chance that he wins the point given that he missed the first serve, and a 43% chance that he doesn't win the point. Now notice this last column, we're multiplying together the probabilities in the given branch and in the conditional branch. So the probability that Federer makes his first serve and wins the point is 0.63, the probability of a make, times 0.78, the probability of a point given the make, which equals the probability of making the serve and winning the point. This is an application of the general multiplication rule. Notice in this particular event, there are 4 different outcomes. Makes the first serve, wins the point. Makes the first serve and doesn't win the point. Misses the first serve and wins the point. Misses the first serve and doesn't win the point. And these 4 probabilities are shown here, and each one of them is based on multiplying together 2 branches in the tree. And these 4 probabilities add up to a sum of 1 because they are the entire sample space, the entire list of outcomes in this problem. Now we're going to look at how to read and use this chart to answer some questions. I'm going to ask a series of questions, and my suggestion is that you pause the video, think about it for a minute, see if you know the answer to the question before you listen to what I have to say to answer it. What is the probability that Federer wins the point given that he missed his first serve? So we're asking the probability of a point given a miss. Well, this is actually given to us directly in the conditional probability line of the tree. Given that he missed the serve, the probability that he wins his point is 0.57. So that's one of the pieces of information that we are given at the start. Second question, what is the probability that Federer misses the first serve and wins the point? Okay, so this says given that he missed his first serve. This is misses the first serve and wins the point. So I'm going to make a little, underline these here. So once again, pause, see if you know what the answer is, and then come back. This is shown in the last line here, the probability that he misses the first serve and wins the point is the probability of a miss and a point. I probably should have said that the other way around instead of a point and a miss, which is 0.2109. So you're multiplying wins the point, or misses the first serve, times winning the point given that he missed the first serve. Third question, what is the probability that Federer wins the point? Well, there's 2 different situations in which he wins the point. He makes the first serve and wins the point, or he misses the first serve and wins the point. So what we're saying here is the probability that he makes and wins the point, or that he misses and wins the point. When you say or, we add, and we add together those two probabilities here, and that gives us 0.7023. Last question. What is the probability that Federer missed his first serve given that he wins the point? Now I want you to notice that that is a different question than the first question, or the question which is what is the probability that Federer wins the first point given that he missed his first serve. This is the probability that he missed his first serve given that he wins the point. So let's think of our conditional probability rule. The conditional probability rule says the probability of a miss given that he won the point equals the probability that he misses and gets the point divided by all the possibilities of getting the point. So there's two different ways that he gets the point: making and getting the point, or missing and getting the point. So we add those two together, and that's the denominator here. Then the probability that he makes it, that he misses and gets the point, is our numerator. And when we divide, we get about 0.3. So given that he wins the point, there's only about a 30% chance that he missed his first serve. There's a 70% chance that he made his first serve. Notice that going backwards is a completely different probability, with the opposite variable being the given. It's a completely different probability in that case. To make sure that you understand how to do a tree diagram and use that to find some conditional probabilities, I would suggest that you do 5.3 number 78 and then watch the video about that to make sure you did it correctly.